R or Python or Rika. Anybody look at, this is one of the powerful tool for classification and linear regression modeling. So today, we'll cover what is a decision tree, and we'll go into the random forest, which is consists of many trees. Okay. So what is a decision tree? A decision tree is more like a support system. When you're deciding something on any decision, you will take a logical decision at one point. Okay, whether this particular is good or bad. If it is good, go to the next step, and you will reach one certain point and take a decision. Suppose if you want to drive to a particular location, so you will take a car from home, hit the main road, then you will take a decision whether you want to take a left turn or right turn. Right? That's nothing but yes or no. Okay? So if you're taking a left turn, okay, you are going up to a certain point, then another junction comes, then you take another decision, whether to take a right turn or left turn. If you want to go to say, one of the shopping center, or you are going to a movie mall, so you take a decision based on what the GPS, give the direction, correct? So similar thing, in a decision tree, we have the decision support tool. Like, it's more like a tree, like a graph. You take a decision based on, whatever data available at the point of node, and taking a, right side or left side, and moving towards, the goal of the destination. So at each point, each node, you are going to check what is the outcome, what is the cost, what is the probability, and going forward, you take a decision and finally reaching the, the end point of the goal. So that's what the decision normally will take it, correct? So decision tree is a similar mechanism where, with the data available, we are going to take, we are going to split the data into two parts at one particular node. Then, going to the both the side of the node and check, what is the next best split, and we keep on splitting until we are not able to split the data. So it gives a kind of direction from the top node to bottom node how we can split the data and take a decision. I'll explain in a graph, or probably in a much better way when we are going to execute the code or something like that. But the underlying principle for any dictionary tree is you are going to split the data into two parts at each decision node, and then they are going to take a decision on the next node how the data want to split, etc., etc. So it will give you a kind of indication, what is the best node to split on, and going forward, we can take a decision. Okay, that is the decision tree. Decision tree, when you're talking about decision tree, just think about normal tree, how the normal tree will look like. It starts in the root and goes to a first level, first branch. Then first branch goes into, the left side or right side. And if I go into the branch, you can have a many small branches. Then, finally only you have the leaves. The leaves, nothing but the individual records in our data sets. So when you go into the first split, you can think of a set of data or a category data which will be split into a particular category. Then moving into the second node, the data set is split into another category. So like the data will be split into multiple categories. Just one second, guys. So decision tree is the same stuff, and random forest is nothing but if you have the forest, you will have a lot of trees, correct? So in the random forest method, we are going to include many trees. Roughly probably by default, we are going to assume the data set will be split into 500 trees or 600 trees. Whatever the trees if you want to mention, you can mention, and the data will be split, and we are going to get each and every tree will give output, correct? What is the output, what is the model, etc. In the random forest, we are going to take all the trees output, we are going to average the output. So when you are going to take the average, it will be closest to the actual whatever we are trying to predict. So decision tree, is based on only one split up, whereas random tree will take the data set and it's going to split the data set into random. It is going to do the random tree, into 500 times and take an average of the 500 trees. Then you will get that decision or the output very closest to the actual. Any questions as of now?
Okay, sir.
Okay. So thing is normal, like when you're taking it one single tree and a random forest, the random forest will consist of many trees. If you look at normal forest, the normal forest will consist of many trees. So similar thing, random forest will consist of many decision trees, and each and every tree will give output. Whether it's a classification or regression. And in the random forest, we are going to take all the trees, we are going to average the trees, and we are going to get our funnel out. That's the methodology we are going to work on it. Okay. So I'm moving to the next slide. This is what the tree element will look like. So if you're going to start a prediction or classification, we'll be starting a new decision tree, correct? So that's a starting point for us. And the first node we are going to split. The red color node is nothing but a root node. Okay. So the root node is the first node we are going to split up for any decision tree based on certain condition. Okay. It may be any numerical condition. Just 1 second. Sure. Decision tree is also similar stuff, like it's we are starting an algorithm and we come to a first point where we take a data and split the data into some of the fields or features. Then the one tree goes on the right side, one tree goes on the left side, and like that it reaches the second point, and the second point they take a decision, and it goes until the last level. The last level nothing but the leaf node, the individual record. So there are certain important elements we need to remember in the decision tree. The red color, the rectangular point is nothing but a root node. The root node nothing but the first split up is going to happen on the particular data set, and it goes into a branch here. So the connecting point between the first split up and the second node, these are the called nodes. Okay, this is the second split up going to happen. The connecting point between the output of the first split up or any split up to the second node is nothing but we call as edges. So the outcome of a split to the next node. So this line is called edges. Okay. So and the orange color one is nothing but we call as a nodes. So this is a root node and this is a normal node. And the root node will split into 2 points or probably 2 or 3 points, whatever the split up is going to happen. And the output of one node to the next node will be called edges. Okay. And the final point where the split up is not going to happen, this is the end point for any split up. These are called leaves. We are calling as a terminal nodes that predict the outcome. So it's more like some outcome is going to come from this point. So this is an important element for any decision trees. When we are going to do the random forest, we'll have many decision trees with a similar output. So random forest is nothing but randomly we are going to take the if you have the data sets which has 20 columns and probably 5,000 rows. The random forest for the first tree it will take probably around 10 to 15 columns and probably around 3,000 rows. Randomly it will choose. And the second tree also will choose out of 5,000 rows and 20 columns, it will choose a selective, probably around, 3,000 rows, another 15 columns. So the columns and the data rows are selected randomly. That's why it's called random forest. So if you're going to split up your 5,000 or 500 trees by selecting a random columns and random rows, the output will be very close to average. You know. So it's very practical, right? If you want to do it or something on a guesswork, and if you select a average from a 5 people, it will be very different from the actual. But if you're going to take the guesswork from 500 people, the average of the guesswork will be very closest to the reality. Okay, so that's what the decision tree is talks about. So let me go into any questions on this particular three elements?
No, Chetan, it's clear.
Okay, good. Ajay, for you?
I want to listen once more because I didn't understand about.
Okay, so if you take any tree, okay, tree, it's from the ground up, okay. It starts from the root, branch, then it's going to the first branch, and it's split up into 2 ways or 3 ways, correct? Similarly, for the data, we can take, if you take a data set, okay, we can split the data set into 2 parts, based on certain conditions, right? Suppose, the data set has age, right? I can split the data set into 2 ways, like the data of the age greater than 30 or age less than 30, correct? I can split up the data into 2 parts, okay? Then one branch will be the data greater than 30 and the other branch will be data less than 30, okay? So I split the data into 2. If the data set has 5,000 records and around 2,000 records has more than the age greater than 30 and the remaining age greater than less than 30. So that's a root branch or something like that. Let me explain the example in the next slide. Okay. So this is a classical example of relation tree. I have a data set which is probably only 10 records, and it has various columns. I have columns like refund, and the medical test status, taxable income, and cheat. Okay. It says it is for the loan application. Whether the particular person cheated or not. This is the final outcome. So this is what we want to predict. The final outcome. Okay. And we have the columns. Okay. Refund. So there are 3 possible columns. These are like the input column. This is the output column we want to predict. Okay. So when we are going to feed this data into our random the decision tree model, okay, decision tree is algorithm within our data science or any other Python data science. When I feed this the data into my the decision tree algorithm, it find out what is the best node to split up for the root node. So it split up okay for me the refund is the first split up. How it determined, what is the value to split up? It's as a separate algorithm. Probably I can explain a little bit about how the split up is going to happen. But the algorithm, decides with some logic, some calculation, some mathematical calculation within itself and takes, okay, for me, for the particular decision tree, the refund is the best way to split up. So it split up the data into 2 parts because refund has only 2 values, yes or no. So the data is split into 2 ways, refund, yes or no. If no means it comes to the final mode, the guy is cheating or not cheating, okay, because he is done the refund, so he is not cheated this the particular node. So this is the end node, but he has not given the refund, okay, then then no, then it comes to the next node, how I can split up the data. Since already I split the data in the refund column, the next 2 possible ways either the measured status or taxable income. Okay, so the algorithm decides, okay, for me, for the algorithm, the next best possible split is the marriage status. Okay, so it split the data into two parts. Okay, so it takes all the no column 1, 2, 3, 4, 5, 6, 7. Out of 10, the 7 columns it goes into this no code, no mode, and this particular the branch gets only the 7 rows because the 3 rows goes into this no column. The yes, the cheated the yes, and this the marriage status gets the 7 rows and decides to split the rows into two parts, whether married and divorced. And the data is split into two branches here. Marriage is no. So if you look at marriage is no single 1, 2, 3, 4. So it's split up into 4 parts where the single is comes to this way. And is married means 1, 2, 3, 4. Okay. If you look at all the 4 married, they are not cheated. Married, no cheated. Marriage, they are not cheated. Married, they are not cheated, or something like that. So when decide to split on this particular node, it check what is the outcome. So it's take the best possible outcome to split the data. So the node gets all the possible because it has only 4 rows, which is they're not cheated. On the right hand side, we have the last column, the taxable income. So if you look at single divorce, I have 1, 2, 3, 4, 5, and 6. Correct. So the 6 nodes, comes into this part, taxable income. Then in the taxable income, this is another decision step. It takes how I can split the data based on this particular column. Since the taxable income is not a a logical field, it's not depending upon yes or no column, but it's basically a continuous variable. So it checks what is the best way I can split the data so that the output will be very clean. So it checks the value. If this particular value is greater than 80, then the cheat it's become a yes. If it is less than 80K, its cheats become no. So every addition step, the refund or the basis status or taxable income, since we have only 3 columns, it takes only the 3 columns. But if we have more than 10 or 15 columns, and the data will split into 10 branches. So whenever it comes to the addition branch and decide to split, it considers this output column. It check the output column and find out what the best way to split, and it takes the value. You want to split on the particular numerical column or the the classification or the logical column and split the data into 2 parts. So this is the way the decision tree is working on the on the background. You no need to give any kind of input. Okay, which column to split first, which column to split second. The particular algorithm in R takes care of everything. Only you need to give the the input data sets and what the output data set. It take care of the splitting, and it gives the output like this, and it's very easy to explain to any business users how the data, what is the first important column, what is the second important column, etc. You can decide. So if you look at, for us, the most important column for us is refund, and the second important column is whether the person is married or not, and third important column is taxable income. So like that, it gives the importance of the variables. If you have more than 50 or 60 variables, it takes only the important variables and split up data sets. Did you understand, Ajay?
Yeah, got it, Sita.
Okay, good.
But Sita, in real time, how can we know the important columns, which are the important columns in the data?
The real time you don't need to understand because the algorithm, the code itself takes, the code checks, some 2-3 methods are there, like, each and every package work on certain methods. So if in the real time you are going to give, what is your output, you are going to give Y, the ampersand symbol, then you are going to give all the inputs, correct?
Yeah.
Okay. So the algorithm takes all the input and decides on, what node to split for the first root node. So it checks, what is the purity, what is the best value I can split up so that the output will be clear on the first node.
Yeah, okay.
Okay, like that it takes internally, you don't need to mention how to split up the data because it takes its own calculation and split up. For example, if you look at, I have the 10 data sets, right, 10 rows. Okay, so when you go here, it checks. Okay, I have out of 1, 2, 3, 4, 5, 6, 7. Okay, 7 no's and 3 yeses. Correct. So it's 70 to 30% split up. Okay, it checks which column gives in my best split up. If you say 1, 2, 3, 4, 5, 6, 7. Okay, so in the refund column also I have 70-30 ratio. Okay. For no, it's no. So when so it is split up. It takes this. Okay, which column? When if I take it split up, the output will be on the right way. So it takes two method called Gini index and impurity, or it checks what is the purity of the split up. So it takes internally and split the data into two parts. Then it goes into the next the branch or the column, and takes the remaining columns and try to split up. Correct. Suppose if you have a coin, okay, you have a coins like if you take Indian rupee, you have the coins of 10 rupees, 5 rupees, 2 rupees, 1 rupees, correct? So you get a bunch of coin, when you give to the shop owner, correct? So the shop owner takes all the coin, he checks, okay, he try to, okay, for me, it looks like a lot of 1 rupees. So he takes all the 1 rupees at one side and remaining coins to the next, goes to the right hand side. Okay, so the left hand side, all the 1 rupee coins are there. Okay, now it's going to the right hand side. He just, looking in the coins what he has and checks, okay, for me, it should look like 5 rupees coins are, higher. So he split up the 5 rupees coins separately and the remaining coins separately. So like that, it goes on one level, and finally he has a perfect split up of 10 rupees, 5 rupees, 2 rupees, 1 rupees. Correct? That's what normally we do when you try to split up anything, a random output or classifications. Probably you must have did it in your real life also, right? When you're trying to split the coin, you have multiple coins. You take all the higher denomination, which has high volume into one side and remaining volume into the other side, then split up the remaining volume. Like that will go until we split up all the coins. Did you agree, Ajay?
Yes, Heta.
Okay. Okay. So the addition tree applies the same method, like it's split up in the topmost or the highest classes, then it goes into one by one and split up the next classes, etc. Sure. Okay. Let me go into the next slide. Okay. So this is a question you asked, right, Ajay? How the tree decide what is the way and how to split up the data, correct?
Yeah.
Okay. So each and every package, we have so many packages to work on the particular decision tree or random forest. So there are two important stuff where we can uh, how that the machine, the decision tree or probably the machine learning take a decision how to split up. One is called Gini index. Okay. So what Gini index says, if you select two items from the population at random, okay, you are taking, you have the coins, from the, whatever, you have the notes, okay, you are taking a notes from your money purse, okay, and you take the columns and, you are looking that, the bunch of notes and taking notes, how much of notes in the same class, how much you have 500, how much you have non-500, and we are splitting that, the rows into two. So similarly, Gini index, what it says, if we select two items from the population, the population may be, if example, like, if a loan prediction, the person is defaulted or non-defaulted, okay. So if you're taking a sample from this particular, population, and you must check, what is the class has the highest probability. The highest probability always, the maximum probability will be 1. which is nothing but 100%. So if you're going to take 10 samples from the population, and if you're checking the gene index checks out of 10, which has the highest probabilities, whether defaulted or non-defaulted. So if defaulted is yes, it takes 60%, then we take that class. So like that it's split up, that's what I explained in the previous class. Okay, so Gini index is one of the method, it takes the population and at random and checks which has the highest population, highest population closest to the pure. Pure means 100% is one class and remaining class is 0%. So like that is trying to split up. Okay, so it works very if the target variable which we are trying to predict is a category variable, either yes or no, 0 or 1, success or failure, and the Gini index does the binary split based on certain values. We saw in the previous example, we are trying to split up with the marriage status or salary above 100% or 100K or below 100K. These are like very binary split, right? Above 100K means if you take any data sets, the candidate will fall under above 100K or below 100K, right? So the output is always a binary. So it tries to split up the data into binary split. So it's nothing but higher than the value of Gini. Gini is a calculation. I can give the formula example where exactly it is. But based on the Gini index, it split the data into two parts. Okay. And there is a package called CORD, which is nothing but classification and regression tree. These particular packages uses Gini method for binary split. We can there are many packages. We can see one of the packages for our sample. Okay. So there's something called information gain. Okay. So let me explain the information gain. Okay. So if you look at the three, the circles, we have three data sets. Okay, or three classification. Okay. So if we look at ABC, okay, the C is totally blue circles, correct? And the C is totally of blue circles. A has a lot of yellow circle and blue circle. So that means it has two classification, and B has a very small number of yellow circles and a large number of blue circles. Okay. So if you look at the C circle, it's totally pure class. It's every object or the record or the observation in the C class is belong to one particular category. That means C is totally a pure class. Entropy of this particular one is closest to 1 or closest to 0. Okay. But if you look at B and C, B is less impure because we have around 70 to 80% of one class and remaining 20% is another class. So this one is closest to a kind of less impure, and for that we need more data. So here the data will go into the next level of split and trying to split up which is the best way to split up. Whereas in the C class, the root node itself will split the data on certain classification. If you go to A, it's very less impure because we cannot identify how the data we can split up, so it required more information. So the information gain when you are trying to split up, it will take a decision. The decision tree when trying to split up, it will check if I split up on the particular column, whether my information will be pure or not.